Hello my dear students, this is Hz.A and welcome to the Hz Physics classes. Hope so doing good. Today we are going to solve the 11th waves question asked in a JEE 2024 exam. So students, the question is in a closed organ pipe, the frequency of fundamental note is 30 Hz. A certain amount of water is now poured in the organ pipe so that the fundamental frequency is increased to 110 Hz. If the organ pipe has a cross-sectional area of 2 cm square, the amount of water poured in the organ pipe, how much? We have to tell the answer in gram. And additional data is given, speed of sound in air, how much given? 330 meter per second. So we have to use this data. So students, before starting this question, remember that the basics of the stationary wave. So whenever stationary wave will form, there will be the superposition of the incident wave and the reflected wave. After that, wherever the displacement is the zero, that is called the points of the node, and wherever the displacement is maximum, that are the points of antinode. Is it? Now students, after that you have to remember that distance between two consecutive antinodes will be always lambda by 2. Okay, and the distance between two consecutive nodes also lambda by 2, and distance between antinode and node consecutive, how much? This should be lambda by 4. This basic we should remember that to solve this question. Okay, so here I have drawn the two situations. First one I will draw without water. Okay, so here what is happen? Here the particles are having the maximum freedom. So what will form here? Here antinode will form. And here the particles are not having freedom. So what will form? Node will form. So I can write here, see, like this. This is which wave, students? This is a displacement wave, no? Not a pressure wave, displacement wave. And remember that here the phase difference between pressure wave and the displacement wave is the 90 degree. And here I am doing the displacement wave. Okay, so see here, this distance, how much here? No, this distance, let's take here L1. Okay, so this is the antinode and this is the node. So if I talk about, this is the situation 1. So in situation 1, students, what we can write here? L1 is equal to lambda 1 by 4, and you know V equal to F lambda. That means lambda how much? V by F. So V by 4 F1. Is it? Value of V how much given? This is the value of V. We can write here 330 and 4 and F1 initially this is the F1. This is how much given? 30. So students will simplify this 0 cancel, and here 11, so it will come here 11 by 4 meter. Now first situation is solved. After that, students, second situation, we have to pour the water. Where? In the organ pipe. Okay, so we have pour the water now here. So when we'll pour the water, now what will happen? That this surface is here. Now what will happen? Reflection will take place from this water surface. Now, so again we'll draw here, now like this. And now this is the antinode, this is the node. So here what will happen? The wavelength of the wave will change. So wavelength will be different. Like here wavelength was lambda 1. So here wavelength will be how much now? Lambda 2. Okay, and this distance how much? Anyhow this distance will be less than L1, so I have taken L2. So in second situation L2 will be how much? We can write here again lambda 2 by 4. Okay, again lambda equal to V by F. That means we can write here V by 4 F2. Again kindly put the value 330, 4, and now where is the F2, students? This is the F2. Is it? And this is how much here? 110. So this 0 cancel, it will come 3 by 4 meter. Okay, now you can see very well the water in how much length? Water in this much length. And this length how much? This length is L2 minus L1. And cross-sectional area is also given here. Na? So what is the volume of the water? Volume of the water means area of cross-section. That means this area of cross-section into length L2 minus L1 here. Okay, so first we'll calculate the L2 minus L1 and then we'll multiply with the area of cross-section. Okay, students, so area of cross-section how much given? 2 centimeter square. We'll go to the next one, please. So area of cross-section is given 2 centimeter square. Now this one. So here L1 minus L2 will be how much here? 11 by 4 minus 3 by 4, and how much coming here? 8 by 4 meter. That means how much here? It is coming 2 meter. Now here this is centimeter. Here also I will convert into centimeter. How much coming? 200 centimeter. After the students, you know very well, mass means density into volume, delta V, and this is given by here rho. Volume means A into delta L, or we can tell rho A delta L. What is this? This is the delta L. Okay, so students, what is this? L1 minus L2. Just put the values please here. Rho how much? You know very well, everything we are solving in a centimeter. So what is the density of the water? 1 gram per centimeter cube into area of cross section, how much given here? 2, and our L1 minus L2 is coming how much here? 200. So here it will come how much here? 400 gram. That means we have to pour 400 gram of water to satisfy the condition of our question.